What is a mole? A mole is the chemist's counting unit. It allows us to relate masses, which we can measure in the lab, to the number of atoms that are or molecules that are actually undergoing chemical reaction. It lets us count the number of atoms so that we can put them into the reaction in the right ratios. So what it is, it's a counting unit, just like a farmer. If a farmer was selling corn to you, the farmer wouldn't sell individual kernels of corn; they'd sell bushels of corn, because counting the individual kernels would not be a convenient thing; it would be a pain. And a baker might sell bagels to a supermarket in dozens. The chemist measures things in moles because measuring them in actual number of molecules is not a convenient thing. So a mole is just a counting unit, like a bushel, a pear, or a dozen. So a bushel has many corn kernels. We could figure out how many. A pear has 2, always. A dozen has 12, always. And a mole, since it's just a specific number of things, is a unit that contains a specific number, 6.02 times 10 to the 23rd things. It's just a big number, because in order for us to get a convenient number out of atoms and molecules, we need a big number. So we need a lot of atoms or molecules before we can start talking about enough to actually put on a balance and weigh. So we use it for convenience, and here's an illustration of why. In a chemical reaction, balanced chemical reaction, coefficients refer to the number of molecules that react. So our recipe in chemistry comes in molecules. It doesn't come in grams. So this means 2 molecules of hydrogen react with 1 molecule of oxygen to make 2 molecules of water. Or maybe 2 dozen hydrogens plus 1 dozen oxygen make 2 dozen water. Or if I had, say, 6 dozen hydrogen, I need half as much oxygen in dozens, so I'd need 3 dozen. Well, if I have groups of things, I can use moles, and so I can say 2 moles of hydrogen react with 1 mole of oxygen to form 2 moles of water. Our balanced chemical equation, our recipe, works in moles, and that's why we need to measure moles. Okay? So 2 moles of hydrogen plus 1 mole of oxygen make 2 moles of water. Now, why is it so convenient? It's so convenient because it allows us to relate number of molecules to the atomic mass on the periodic table. So where does it come from? Where does this 6.02 times 10 to the 23rd come from? Well, we know that the mass of a proton is about equal to the mass of a neutron, and that's equal to 1 AMU, and that's equal to 1.66 times 10 to the minus 24 grams. That's a small mass. But I can say that 1 AMU, if I find this ratio, is equal to 1.66 times 10 to the minus 24 grams, I can say that if I divide 1 divided by 1.6 times 10 to the minus 24, I get 6.02 times 10 to the 23rd AMU per 1 gram of protons or neutrons. So basically, that allows me to say that however many grams I have on the periodic table in atomic mass, I can convert to number of atoms. So 1 gram of protons, which is 1 gram of hydrogen atoms, basically, if they have 1 electron each, will have 6.02 times 10 to the 23rd atoms of it. So from this, we get a really important relationship. We get 1 mole equals 6.02 times 10 to the 23rd things, but equals the molar mass from the periodic table in grams.